Hey, welcome back, DevGod here, and today we are going to be doing another programming mathematics video. This is actually going to be the first episode in a new series I'm going to be starting here on YouTube. Basically, explore mathematics, explore programming, explore like how they relate to each other, and of course, I'm a VTuber. So I thought we'd start things a little bit easy, something I've been kind of like wondering my whole life. Like, what is the probability of playing tic-tac-toe? Now, I know, like, some people are like, what square should I start with? Like, what place should I start with? But I was more thinking along the lines of, like, what is the best? Is it best to be the first person to start or the last person to start? Like, who has the higher chance of winning? And then also, like, how many games of tic-tac-toe just result in a tie? So, can use mathematics to solve this, but it is a little bit tricky. I saw some solutions online, but I didn't really like them because you had to like have a existing knowledge of like what combinations wouldn't work, what would work. Yeah, I didn't really like the mathematics side of it, but the programming side I find a little bit easier, at least for this specific tic-tac-toe problem. And it's really easy to do because basically you're just simulating a large amount of games until you get to the point where your data and your percentages for probability look basically the same every time you run it. Especially like once you like round it up from like the decimal points. So we will see what the final results are of that. Okay. Of course, my name is DevGod, and if this video does good, there will be more of these kind of programming mathematics lectures. We'll have a lot of fun together. I'll show that this isn't like a very scary thing to try to do, okay? Here's some of the goals we're going to have for the first episode. So, we want to have a lot of rounds, right? Because we could play a couple of rounds, but think about it. If we were to try to play a million rounds of tic-tac-toe in real life, that would like take forever to do. Okay. But when you use programming and you use computers, it makes life a lot easier because you can play those games in like milliseconds, like really fast. In fact, if we weren't using Java and we were using a compiled language instead of an interpreted language, which we'll get into future episodes, it'd be even faster. But even then, Java is still pretty fast. I can like whip out a million rounds in a couple of seconds. They do a really quick calculations based on those. Um, Also, another surprising thing was I was looking up online. Apparently, a lot of people grew up with X being the first person in tic-tac-toe to play first. See, because when I was growing up, it was always like circle or like O goes first. I've never heard of like X goes first, so that's kind of how I went ahead and programmed this. So basically, O is going to be the person designated to go first at the start of every single round. And then X is the person who's always going to go second every single round out of like these billions of rounds. Right, so the first main goal is make sure zero always goes first and to simulate like 1 million rounds of tic-tac-toe. Um, and then what we want to do after that gets done is use Java to display like the amounts and percentages. Basically, we're running simulations to get data, and then we want to like display the data to the user. Now, what we're just using is the console. We could get more advanced and make like an actual like graphical user interface, but we're sticking really, really simple, really easy peasy in this tutorial. And we're just gonna like display some text strings with those variables. Okay, and then the third goal, we're going to be using Java, not JavaScript. They're different languages. We're going to be using Java with the Eclipse IED, so basically integrated development environment, basically your standard code editor, to like write Java. You can actually write other stuff if you install the right packages for it. Eclipse is pretty good, but it's definitely best for Java. It's best well known for Java. So we're going to be using Java and Eclipse to create the actual tic-tac-toe simulator. And then we're going to learn about like really basic things about Java. So like the main things that are powering the script, I think like the main takeaway, the main ideas to learn about here are System.out.print, which is actually going to send like, or I shouldn't say send, it's going to print, it's going to write. Yeah, write's the right word. it's gonna basically put the variables into the console for us, like as a string, and it's gonna like output that. It's like the out, and then it's gonna outprint to our console log in Eclipse. And if we were to actually export this, which I actually didn't, but if you were to export it, then you could get that to go to like command prompt. You can do like a lot of different things, but System.out.print is like the easiest to get started with. And then we have Java.util.random. That's basically going to give us access to Java's like random value generation. We can actually like randomize which spaces of the square are going to get filled up, and all of that. And then also we have like the really extreme basics that we're going to be learning about, like really any programming language in general, which is we're going to learn a little bit about arrays, a little bit about Booleans, integers, voids. We're going to learn a lot of like really fun programming stuff. Basically, and I put that in as like a subheading, like the basic building blocks of programming with Java, but really these are the basic programming building blocks of any modern language. And I think like the main goal, or like the main question we want to like ask, right? This is like what we want our program to answer. What are the probabilities of a tic-tac-toe game, and how can we use Java programming to find out those probabilities? Because like I said, there's mathematics, but the mathematics are kind of, at least some of the solutions I found online are kind of assuming you know the amount of combinations already, which I mean, for a 3x3 grid, that's good. Then when you get into, like, if you ever like wanted to play tic-tac-toe with like a million by million grid, uh, which that'd kind of be insane, but basically the bigger the grid's gonna get eventually, like that'd be a lot of counting of like each possible combination that could result in a win, loss, or draw. So I thought that programming would be a funner, more interesting way of showing it. Math people, please don't hate me. So go on to the next slide really quick. There we go. So like one of the first things now, Eclipse generates this like automatically. I think some like IEDs or like some code editors aren't going to give you this, and you'll just have like remember it and like copy and paste it from other scripts. But most IEDs include, and I know for sure Eclipse does, it gives you this automatically. So this is like the basic structure of a Java code file. Is that the right word? Yeah, code file, code class. So we have our import statements, and that's just going to give us access to Java libraries, and also if there's like other code like APIs or libraries we want to use, like LWJL, or if we have like a Perlin noise library, or just some like external things, we can use the import to get access to those libraries. So without the Java utility, we wouldn't have access to the random numbers. But then on the other hand, we don't necessarily need like a import Java, or at least not for Eclipse, because it automatically knows that it's Java, and then that's like what the system thing belongs to, and like these basic variables. So it's basically you get the bare bones, and then you can use your import to get like additional features to your code. Basically, I mean that's like the most generalization you can get of import statements. So anyway, yeah, you put all your imports there, and then you can go to your public class. Now, usually the first what's it called? The first script is going to be called public class main in most programming languages. I think some of them do program. Although this can really be whatever you want it to be. But this is like the usual that's automatically generated. So we just go with that. So we'll just call this public class main. Since I really do only have one class now, this was like a bigger Java project that I was actually putting a lot more time into. I would have like multiple classes with like really descriptive names. Main is good for now. Like we know what it does, right? And then we just initialize our variable. So we have a static int board, which, as you can guess, it's going to be a board array. Now, if you remember from programming class, arrays are lists of numbers, basically. Or not really, I shouldn't say that, not a list of numbers, but it's basically a list of a data type. So in this specific instance, board is going to be equal to numbers, because then I can use the numbers to like change the state of if it's blank. 1 is like a 0, 2 is an X. I can really like control that just with numbers instead of like putting symbols there, but the numbers represent symbols, which we'll get into a little bit later. This could really be anything. Could be a string array, could be a double array, float array. Could be an array of arrays. There's like multiple different kind of data types. It just so happens that this board is going to be a int array, which is basically just a list of ints. Really like a table of ints, collection of ints. Okay, and then we have our static Boolean. So Booleans are just true and false. They're basically going to be used for your if statements, your testing, your whatever. Basically think back to binary, right? 0, 1, on, off. It can really only be two states in most programming languages, including Java. That's going to be your true and false. Now since I have it so that O turn like is true, I'm going to set that to true to make sure O goes first. If it's false, X goes first. And then I just make sure it's always set to true at the beginning of each round, which we'll see a little bit later. And then we have just some other ints that I'm going to like do like arithmetic to, like some addition to. We have turns, the amount of wins that O and X has, and then ties, like amount of tied games there are. Really, yeah, turns we'll see a little bit later, so I'll explain that. Okay, next slide. And then basically once you get all of your variables of like all your data types configured, those are your global variables, by the way. There's going to be some like internal variables, but those are like the big ones. They're going to be global. Any void within this class can access them. Speaking of voids, yeah, actually this is our first void. Public static void main, and then you have like this kind of confusing like string array of arguments. That's basically just gonna tell Eclipse and the like compiler and stuff, or interpreter I should say, since Java is an interpreted language, that this is gonna be the first void that is triggered, like before any other voids are triggered. So that way it just knows like which one to do first. Then arguments is going to be like your console log and things like that. It's basically a way to tell the interpreter that this goes first. Right, so then we're going to have like a local variable. Now those that we just assigned were public variables. This is going to be a local variable, I, for iterations, I believe it's called. Now this could really be anything. I just like to do I because it's like the classic I while statement. So we're going to set I to 0. We're going to have like a while statement, like while I is less than 1,000,000, we're going to trigger this code inside of this while statement. And I cannot stress this enough. You got to make sure you have your I++. Just fun fact, I'm not sure if you guys, when you get into the programming world, a lot of like infinite loops, right? So if you ever have a program that just like freezes, doesn't respond, you have to like Control-Alt-Delete it. I think sometimes if they're really bad, even like Alt F4 doesn't work. That's basically your classic infinite loop error. That means that this statement in the while is always going to be true and can never be false. And if it's always true, then it will never end. Unless, of course, you like Control-Alt-Delete it, and then it's like a whole mess. And it has to report that problem to Microsoft or whatever. Anyway. So I starts at 0, and then we're just gonna like run this 1,000,000 times. And then like once 1,000,000, like so like da 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 da, right? Run, 1,000,000 times, and then eventually we get to the point where I is equal to 1,000,000, and then when we think about it, it's like, is 1,000,000 less than 1,000,000? And the answer to that is false. Then since the Boolean now is going to equal to false, we're going to leave the while loop. And then we can finally display the results. But then if we forgot that I++, we would just be in that while loop until Control-Delete time. And then we have some like other voids that are going to be coming up soon. So we have the reset board. Or I shouldn't say array, voids. Voids are functions, basically. And these are just curly brackets. This is the code that's going to be executed. You'll see, this is like go to. It's basically collections of code that you can then like jump to, and then you can do more code, like in a very general sense. So we have a reset board. It's going to do what it sounds like. It's just going to make sure the board is set to 0. We have our play. We have our display board, which is going to display every single tic-tac-toe board as soon as the play void is done. And then we just keep on looping, and then finally, like I said, once we get done with that while loop, we can go to the display results. Okay, so pretty simple. Okay, now here's a couple more voids. They're kind of smaller voids. They're not really the meat and potatoes of this program, but they're still important. So I'm just gonna explain three of them right now. So we have a public static void reset port. Oh man, my AC just turned on. Which what this is gonna do is it's gonna reset some variables. Make sure it's gonna set turns to 0. Going to set O turn to true. It's gonna set board to a new array, which looks kind of confusing at first, but that's basically clearing the board. Make sure there's no symbols on it, and it's performing its like next calculations. So it's basically resetting the values for the next round, so it's like a brand new slate, but it is a different round. Right, next we have the display board. So basically we're just using a whole lot of those like System.out.print to print information to the console log in Eclipse. So one of the things we're doing is we're printing I, which I should actually explain that. So we have parameters in these two functions of int I. Technically these are different variables, but we're setting them to be the same. Because if we go back to here, we are putting I inside of the curly brackets, so this I from the while statement here is going to like carry over when you jump to that line of, or to that collection of code, that void, if you will. So right, if I is equal to 0, then we're going to display board 0. And we'll go over here and like look at this. So display board, then that int I is going to also be equal to 0. So then we're going to print a 0. We're going to print some dashes. So basically these are called parameters. And they can just like, they're basically used to transfer local variables from like one void to another. I mean, that's like the basic gist of it. And then you can also like use them to like really optimize your code, like limit those lines of code and stuff that you need. Like you can create voids and then you can give them variables like change their output. I don't know. Basically, it's like a really cool trick to know. Basically, the lot of possibilities are possible when you do parameters in your void, so it's a good thing to do. We have dash dash. We're doing this like /n basically as like an enter key press. So that's just going to make a new line in the console for everything to output to. So that way we don't get like a lot of confusion. What else? Yeah, it's just going to make like the console output a lot cleaner. Okay, where was I? I'm just like really excited. This is a really good pilot episode. So we have our display board, and then we're also accessing different points of the board array. So we're seeing like, oh, what's the value of 0? Print that. Plus, we're going to add like a comma to this string. Then we're going to go to 1. And then we're going to see the value in the one position, or the one index of the board array, and we're going to print that value. So basically we're getting values. We're like checking the board array, then we're like offsetting like where it's checking for the position of the array, and it's going to grab that number and then print that there. So basic array stuff, kind of confusing, but just remember it's like a grocery list. It's like a collection of data, and then the number that's going inside is basically telling the Java interpreter like where in that array should the data be grabbed. And once that data is grabbed, it's going to export it, like in the simplest sense. Okay, and then last we have display results, which is going to do two things. So we're going to have like one line dedicated to like showing the amount of times O wins. We're going to show the amount of time X wins. We're going to like show the amount of like tied games there were. And then we're going to show the amount of rounds. And it's the same idea. The I from the while statement in the play is going to transfer here. So if I, here, let me actually pull it up. So if we get to the point where like I is equal to like 999,999, it's going to go into, or actually, no, that's wrong. We get to like a million, right? A million is not less than a million, so that's going to be false. We're going to escape the while loop. And we're going to display results, but then our I is going to be equal to a million. So then we go over here. Let's see here. So it's going to be equal to a million, so that's going to say rounds and then plus a million, right? And just remember, it's not like you're, and I should also say that too. It's not like you're plussing letters and numbers together. You're just like combining strings, basically. Now, if you're adding two ints together, like 2 plus 2 would be 4. But right here is basically saying combine this string, which is your text, your label, or whatever, basically, and then you're combining that with your actual variable, but like in a text kind of format instead of a like arithmetic, let's do some addition or subtraction kind of format. So I hope that makes sense. In strings, you can tell the difference easily because strings can be numbers, but those numbers are going to be inside these quotation marks, right? Strings are meant to be like these text kind of things. So, and they're kind of like dialogue in a way. So we're going to put those in our double quotation marks. Okay, so we do all that. And then we do another /n, which remember, that's going to just be like an enter key press into the console log. And then we have some more system prints. And then these are basically going to, there's a lot of stuff going on here at the bottom. This is basically turning our integer, right? Because we made these integers to make sure they're whole numbers. We're going to turn them into a double, though. And we can do that by doing what's called a cast. We're adding a cast to it. So by adding like this parentheses, I think that's what, yeah, parentheses. Parentheses, double, parentheses in front of our like integer variables. That's going to make them turn into, they're still going to keep their value, but it's going to turn their data format into a double. And then we're going to divide it by I, which remember, I is going to be a one-time, like, a million deal because it's going to transfer from a previous while statement. So it's going to be like the double of O wins divided by I. And then we're just going to times it by 100 because I wanted to have this in like a percent-like format. And this was kind of like the easiest, quickest way I could think. We are going to make it 100f just to make sure we do keep the like decimal points as needed, so that way we can like round properly. Although really that could be like 100 dot 00, which basically the only difference between a double and an int is doubles have decimal points, but they keep pretty much the same value. And then a float is going to be less precise than a double, but a float is going to be, you're going to use f instead of putting in decimal points. You're basically just going to make sure you have an f in front of it. It's going to have like less floating point precision, but it's going to be better for performance, although we really are just talking milliseconds. Yeah, so yeah, I hope you guys are still here. And then we're just going to like round that to make sure we don't get any ridiculous like scary decimal point numbers. We're just going to round that using your traditional like rounding, like you learn in math class. So anything 5 and above, you round it. And then we're just going to add one character. Basically, this is another string just for a percent sign at the end, so that way they know it's a percent. So really what we're doing is we're just like turning them into format so they keep their decimal points before we round, so the rounding is accurate. And then we're just like dividing the amount of wins and the amount of ties and everything divided by like the amount of like rounds that the while loop run. And then we're just going to slap, we're going to round that, and then we're going to slap a percent sign at the end. Okay. So I hope you guys are with me so far. That's like some of the generic stuff. And I think I forgot to mention too, is like one of the magic things about this is like literally less than 100 lines of code. I will be putting this in a GitHub as soon as I can get a new one created. Maybe I could put this in comments or something? I don't know. I'll make sure that this is a copy and pasteable format, but definitely this is here so I can kind of help explain like what's going on, thought processes, basic programming logic and stuff. Okay. So we have our holy grail, our play function. So just keep in mind, this is not the same as the main, because the main is basically how, now it really can do it anyway, but like how I like to do my mains is you just put a lot of voids in there, and you like make sure to name your voids good so that way you can like really see what's going on. Technically, I could have thrown all the code in my main, have like a really, really big main function, and just call it a day and the interpreter wouldn't care. But the problem with that is, like for readability wise, I care because I gotta be able to like read my code. So what I like to do is I like to break things down in steps, right? Those steps being my voids. And then I make sure to like name those voids. So then instead of like having to look at hundreds of lines of code, I can just go to my main and I can see like a step-by-step like what's happening. Like, oh, reset board. Then we're going to run a round of simulation. Then we're going to display the board. And then we're just going to do that in a while statement and then display the results. Very easy peasy, lemon squeezy for you to understand as a programmer and other programmers like see what's up with your code, see what's happening. Okay. Basically going to make your life a lot easier. Also, I sinned. I did not put comments on this. I really should have, but I was kind of in a rush. Luckily, this is simple, at least to me. But if as Java projects get bigger and as like more and more people are on your team, you'll want to make sure to put comments on your code so they know what's going on and it's good for like future reference and stuff. But this was just like a quick thing I made this morning. Okay. We are here, chat. Or I should say we are here, viewers. We are here, fellow programmers, fellow elves. Public static void play. This is gonna be the loop that actually simulates a tic-tac-toe round. So we have random, right, equals new random. So that might seem a little confusing at first, but here, I'm gonna explain it for you. So random is like another data type, but it's a non-static data type. So what that means is you can do new on it to like make it kind of like an object. Like, I don't know, it's like really hard to explain, but this is how you can initialize a random void that's included with your utility. So this is just kind of like what you do. So just know that like capital random is like your data type, your descriptor, if you will, your field, whatever. And then random lowercase is your actual variable name. And then equal to new random is just a new instance of random. Okay, I hope that makes sense. And then now that we have this random defined, we can use it to easily access like the random functions that Java library has. Which by the way, that is included with the default Java, I believe. I forget what version of Java I'm on, but that basically comes with pretty much most of the Java versions, at least all of like the modern ones. Anyway, so we're gonna do int ID is equal to random, right? Our function dot, or I should say our void or object. Ugh, and I just cannot talk today. Random dot next int, and then we're gonna put a 9 in there as our parameter. You might be thinking, why 9? Well, our board goes from 0 to 8 because arrays are kind of weird like that. You don't really start with 1, you start with 0. At least 99% of programming languages, you start with 0, besides like weird ones like Scratch or Perl or whatever. So it's like really like 1 to 9 squares that could be filled, but we're counting it as 0 to 8 because that's how arrays work. And then to get a value from 0 to 8, because you go 0 to, or I should say like for the next integer, you can get a value between 0 and whatever number you put inside of the parentheses, like whatever your parameter is. So in this case, we're going to get a random integer from 0 to 8, which is very good because our board array has squares for 0 to 8 spaces. We're actually really good there. Then we're going to go to a while statement. This is going to be a little bit different than our int I while statement. Oh god, I can't talk today. In that we're checking an array, and if it's greater than 0, we're going to run. Right? Looks scary, but here's what that actually does. 0 is a blank space, right? And when you're playing tic-tac-toe, you can't like put an X, for example. If like an X is in the first square of the board, you can't put a circle there. You have to put your circle in a blank spot because that's like where your symbols have to go. So what this is doing is basically making sure that squares are not overwritten. And if they look like they're going to be overwritten, i.e., the value of the board array at that like ID position or index, I should say, is greater than 0, i.e., it is not a blank space, we're going to give that ID a new value between 0 and 8. We'll just like keep doing that until like we get an empty value. And then like once we do get an empty value, we'll leave this while go over here to like if 0 turn and board ID is equal to 1, else board ID is equal to 2. That's basically saying as soon as we find an empty space, we're going to see whose turn it is. And if it's a 0, if it's O's turn, we're going to put a 1. If it's X's turn, we're going to put a 2. And remember, we can't really have a symbol array, or at least I couldn't really figure out an easy way to have a symbol array. So I'm using an integer array just because I guess integer arrays are fun. So I'm going to have it so 0 is represented by 1, and X's are represented by 2. And we're basically just seeing whose turn it is. And then we're going to fill the appropriate symbol for whoever's turn it is. And then we go to O turn, which is basically O turn is equal to exclamation point O turn. This is a really fun line of code, because how Booleans work is you have a Boolean, which is a true or false. But then if you put an exclamation point to the left of your Boolean, then you inverse it. So true becomes a false, and a false becomes a true. So if O turn is true, we're going to set O turn to like the inverse of true, or like the opposite of true, which is going to be false. So it's basically a really cool way of turning a Boolean to the other value, turning it on and off, turning it to a 0 or a 1, turning it between states or whatever. So we're just going to change the person's turn, and then we're going to do turns plus plus. I'll get into what turns plus plus does in a little bit. This is basically another infinite loop prevention to make sure our program doesn't freeze on itself, and also that we don't go above things in the array. Okay, and then finally we're going to check, now that we have our squares filled, we're going to check if there's a winner, if there's a tie, or if we have to like keep playing this until we have a winner or a tie, right? So I have a Boolean. It looks like a void. This is going to be a Boolean, I promise. We're seeing if the Boolean is false, right? So if there is a winner, that true is going to become a false, and then we're no longer going to play. If winner is false, we got to turn that into a true. So then that way we execute this play here, and then we loop through the code again. I hope that makes sense. So basically, if there is winner, we're done. If there's no winner, we have to play. And then we just put that exclamation point there so the if statement does its job. Okay, so then I can show you really quick what the isWinner Boolean looks like. Here is the isWinner Boolean. This looks a lot like a void. Here's what we gotta remember between voids and like variables that use this structure. Voids basically do not return, or at least most of them do not return. But then if you're having like an int with code inside of it, or if you're having a Boolean in this case with code inside of it, I got hiccups. Then you have to have like a return value for it to return as. Okay, so that's why we have a lot of return. And basically what's happening here is we're just like checking the board to see like combinations that could result in a win or a tie. So like we have like a lot of if statements here. It's probably really messy. I really should remake this, but this is one way to do it. It's okay. Probably a better way, but what do I know, right? So for example, the first one, if the position is if board array at position 0 or index 0 is equal to 1, and board array at the index of 1 is equal to 1, and board array at the index of 2 is equal to 1, it's basically checking values within the array. Because remember, this is kind of going to represent like a grid-like shape. You'll see it when I run the console. It's just like checking, like, is the first row filled? And if it is, we're gonna like add 1 to O wins. You could do plus equal 1. I like to do plus plus just because it looks really fun. And then we're gonna return a true, so that way the play loop can not like infinitely loop forever. And we're gonna do that for every single combination for both X and O. Or in this case, as I'm representing them 1 and 2. We're gonna do some if statements. And for those who don't know, and basically is just like and symbol is going to make sure that all three of those are true before returning the if statement as true and like running the code inside of it. So if like one of these was going to be 0, but the other ones are equal to 1, then it's going to know that that's not a row of like circles, for example, or a row of ones. And then it's not going to run that code. And it's going to go on to the next if statement. And then it's like if, and else, another if, and then nothing. We're going to return, and then last else, we're going to return false. Meaning there is no winner, chicken dinner. We got to redo the player loop. The play loop, I should say. The play void. We got to loop through that again to see if we can get a winner. And this is where it comes into play. So one of the last if statements I have here in this like else is like if turns is equal to 9, then we're gonna add 1 to ties, and then we're gonna return true, basically meaning that is a tied game. Because think about it. If all of the like that is what a tie is. If all of the squares are filled, and there's no, an X did not win, and O did not win because neither of them were able to like form a horizontal row or a vertical row or diagonal row, that means there's no winner, so we gotta tie it. So that's basically what it's doing. And I got if turns is equal to 9, basically to prevent an infinite loop from happening. Because then without testing for a tie, let me actually go back to play void. Without testing for a tie, we would just be stuck in this like infinite loop with the board, because like the board would be completely filled up. All of the values in the board would be greater than 0 if we were not testing for a tie at the end, like after 9 turns have passed. Since like 9 is the length of the array. So we're basically kind of confusing, but basically we gotta test for the ties to prevent an infinite loop within the play void. Okay, oh, I just lost my train of thought. Yep, and then so we just keep on doing that until we have a winner or a tie. And then if we remember, we just go back to the main void really quick. And then now that the play void is done, we display the board, and then once we do that a million times, we display the results, and then we have data for 1 million rounds of tic-tac-toe. I can actually show that really quick running. Let's go ahead and go into Eclipse. Okay, welcome back. I hope you had time to type all of that code. I was going to film an Eclipse, but I'm not sure how well the video resolution is, so we're just like trying some different methods. Making sure the code is nice and crisp. That was actually a Google Slides I did. Anyway, so now that we're back to the code, this is what Eclipse looks like. Right, so we have our code here. We have like different projects that I'm working on. You can just kind of go into there. A lot of random stuff that I haven't really finished. Then we have our main.java. That's what was created. We also have like all of our code here. I just like wanted to make sure because I have this all in one file, right? So I like took separate pictures of it, but really these voids are in the same file. Now you could put them in different classes, but that kind of sounds like a topic for another video. Which is cool. So this is our main Java, and we can go ahead and run it inside of Eclipse. We could also export it, but just running something like this in Eclipse is like the easiest way to go. Then you have to like try to get like a JDK, everything, JRE. So we'll just go ahead and run in Eclipse just because that's the easiest way to do things without having to like set up exporting stuff. And we see that that actually ran really quickly. I will make sure to zoom in when I video edit it. But yeah, it shows our tic-tac-toe boards represented by integers instead of symbols because we like to have fun like that. Shows that it's gone a million times. Now it is going to say like 999,999 times. Remember, that's just because arrays are weird. Instead of going like 1 to a million, it's going to go 0 to like your 990 whatever. So just know that it is actually a million because we are counting 0 as a number. So if we were actually to scroll all the way up within our, that's weird. Let me scroll all the way up, so you'll just have to take my word for it. But starts at 0, goes all the way there, and once it hits 1,000,000 round, it's going to display our information. So we got the we got like the amount of O wins, we have the amount of X wins, ties, and rounds, which is going to be 1,000,000. And then below that, because we did like that /n, we're going to have our percent, and our percent. So the exciting thing about this, what is exciting about it? I will tell you what's exciting about it. We can see that, let me zoom in here because my eyesight's bad. By using programming, we were able to confirm that O is 58%, or well, I shouldn't say O because I guess some people play it differently, but how do I say this? It's like the person who goes first in tic-tac-toe has a 58% chance of winning, and then the person who goes second, which I'm representing by X, has a 29% chance of winning a tic-tac-toe game. And then about 13% of all tic-tac-toe games are going to result in a draw. Now, how accurate is this is up for debate, because as we remember looking at the code, this isn't really human players, it's like completely randomized AI that's not really thinking, since it's literal like randomized numbers every single round. Now, if I can talk. Now, there is a little bit of thinking because it is able to tell the difference between a blank square and a filled square, and then make sure to go to like a random blank square. But other than that, it really is like a truly randomized player that's not really using intelligence. But it is still probability. So this is like the probability of two randomized computers competing against each other that don't have any real AI but are using random numbers. I should put that out there, yep. But yeah, this is like really interesting because we were able to loop through like 1,000,000. You saw how quick that was. Even like using Java as an interpreted language, we can go through millions of rounds of tic-tac-toe in a matter of seconds. And in fact, if I optimize this code better, we might even go like milliseconds, maybe. Who knows, right? Also, it does take a lot of like a little bit of time. We're talking milliseconds, but eventually, every millisecond counts, I guess. It does take time doing those if statements. You really don't want to be doing those if else's, especially as like your project gets bigger. You want to like look for opportunities to do switches and optimize your code. That's going to be a future video subject. And then also another thing you can explore with math is the higher you go, eventually get to the point where you can verify probability. It's like assuming, infinitely, what is the probability? Like, how do I explain that? It's like the more rounds you play and the more data you collect, the more close to the true probability you're going to get. So I ran that a couple of times, so I know that those values are pretty consistent for 1,000,000. Now, if we were to do something a lot less, like 10, then we would, so like if we change that like 1,000,000 to a 10 in that while statement, I can just show you what's going to happen. There's going to be a lot more data variance. Okay. Editors know. I'll make sure to zoom into the console log for you guys. So right before we were getting like 58 and 26 and 13, and I was running that pretty consistently throughout like my multiple 1,000,000 round tests. But now that we're doing a 10 round test, we can see that the values are more varied. So like instead of like getting 13% ties, we're getting like 0. Wow, we got like 0 ties that round. We're also seeing it like more O wins, more X wins. We got like a 60%, a 40%, and a 0%. Then that's going to vary a lot. So if we like exit out of the console and we run that again, now we have like a 40%, a 50%, and a 10%. We can run that again. Yeah, like another 60%, a 10%, and then like, wow, a 30% for ties. So as you can see, like when we're running it with 10, our data is just all over the place. So it's like really hard to see like if that's the true probability or if there's like variations in the data, just because it's like a very small data set that's not like representative. Because like think about it, 10 out of a million is only like a 0.01. Oh man, this elf princess is not good at math in my head. That's why I script my videos. Um, but basically, like 10 out of a million is going to be like a very small percentage of the data representation. Which you've probably heard about that if like you do surveys or if you like do whatever. You want to have the most amount of data. The most amount of data is going to be the most truthful data instead of like this kind of like cherry picked out of like 10 rounds. Which goes back to our idea that programming is useful just because you can do like get a large amount of data in a very short amount of time versus trying to like play a million rounds of tic-tac-toe in real life and struggling because that's going to take it forever, right? Then we run that again. Oh, whoops. Hang on. Okay, there we go. Run that again, set that back to a million, and we can see we're back to those very consistent values that we saw before. Getting like our 59 to 58% for O, getting like our 29% for X, and we're getting our like 13% for the amount of ties. And I think that about wraps up the video. So, yeah, takeaways from today. Java, pretty easy language. You just gotta know your building blocks. Takeaways for probability. You gotta make sure you have large data set to like avoid the data like variations and like make sure you have like the most truthful, most accurate probability chances. Also for our question, yes, the first player, at least with two randomly generated AIs, the first player who goes first in tic-tac-toe has like literally a 50% advantage, and the second player has a 29, very close to a 30% chance. And then it's only really a 13% chance of a tie, which I remember as a kid playing a lot of tic-tac-toe, there were a lot more ties than that as a kid. But of course that is human versus human and not like completely random computer versus another completely random computer opponent. Also, yeah, like in the future, if I ever want to do a sequel to this, I would definitely make the AI a little bit more advanced. So I'll let you guys know if I ever make a sequel to that. And yeah, takeaways. We were able to print to the console using our System.out.print. We were able to do a lot of like very interesting things with Java. We learned a little bit about random number generation, a little bit about, really a lot about Java, right? Let's see if I can actually zoom in. Okay, no, so I can't remember how to zoom. Okay, I'm gonna have to like relook up how to zoom in. Oh man, I'm so close to like control scroll, but yeah, every IED is different. So yeah, I had a lot of fun today. Please like and subscribe so that I know that this series is doing good. I think these programming videos are going to be very helpful for people. And yeah, that's how you can make your own tic-tac-toe simulator. I hope you guys like that. Make sure to like and subscribe for more amazing programming VTuber content. See you guys next time. Peace.